a funny comment and no one heard it.
He went on for half an hour about how he can't find a new tier shirt.
And I don't remember what it is.
And how they don't make them for
Because it was a
full-size
great
people.
comment.
This is my hair back.
It was very underappreciated.
A little bit.
Ooh, my and then those other women.
Did I put something in a problem?
Oh yeah, please put it the other way.
Oh no, mine does that other.
I
Yeah,
put
put it the other way.
I put a 3P here, right?
Yeah.
Yeah.
Okay, so I forgot to
Other
write
way.
down. But I did it here.
Other way. Other way.
We're already a minute into the recording and we haven't even started.
Did you get my Viva impersonation?
Yeah.
Okay. I'm gonna leave it
That's all.
because I'm dealing with my solution. Okay.
Peer review. Basically.
And this is 2EI.
There, my hair's okay.
They have to make like a marker, like a 4 sides, like we pull the front at once.
Patents.
Okay.
That exists.
I know that
Very
exists, so
unrelated.
I need it. Okay.
So it's not they should make, it's I should buy.
Yeah. That's what I meant.
We should make available in my hand.
Right, left.
I actually screwed it up here.
Okay.
Okay.
Keep going.
Okay. This is equal to. Now, okay, there's one other thing that we have to add here. I'm opening up the hinge, and that is a force from opening the hinge.
Point it up, point it up, point it up. Yes!
I pointed it down.
Well,
Can you put the 3P on there?
Huh?
Yeah, put it
I
on
don't
that
creepy
side.
on the other side.
No.
I have to go through my solution, I'm sorry. You want me to go through your solution? Fine.
I'm gonna actually just erase everything I did and just start copying.
You can go through my solution, Ralph. I'm pretty sure I did it well.
Okay, so we have,
Where's my eraser?
this is equal to 3P per L.
Yeah, you're gonna have to watch out because you're actually like directly in the line of video.
Well, I think you're copying.
Yes. Minus.
It's a good
You're
quality
lucky
eraser.
because
Can I borrow this?
Kind of use my notebook. Just want to hold it up.
Yes? Everyone agree?
Um.
Okay, everyone, if, at least follow.
What's the
Yeah.
Watch it.
Whoa.
Where's
What's
the
the
eight?
8 coming from?
From
Eight?
the 3P.
That's from the
That's formula.
That's the displacement table.
Jenna.
I wish I had a projector with the like he has, with the displacement table just on the
Yeah.
wall.
Yeah, Schmooling's awesome.
Okay. That's delta BL. Now, for delta B right, I have 2, 5, and 1. I'm going to do it back here. I need it right here. You know what? Two, three.
Oh yeah, I had 16. Yeah.
Here's the beam, okay? I'm literally using this as the beam. Okay? So here's our
Why
supports.
did I use H's?
Everyone see that I'm using this as the beam?
Oh.
Because I want to draw it right here. Okay?
Jenna, please.
So I have B, 3B. It's actually good. It would be the 2EI one though. Okay. 4PL. 2P. 3P. And a force from breaking the hinge, G. Okay?
Can G go the other way?
Again, I did it. I wanted to keep B and G in the same direction. When I take this section away and this section away, so I'm just left with this part. Okay? I'm left with B, 3P, 4PL, 6PL the other way. Be careful with the directions of the moments here. And 2EL. for a second, and I'll show you something about the reactions. When I do the delta L equation, I also like to do the reactions in terms of what I have. In this case, what do I mean? Okay?
What's this?
G. In this one, on the side, I'm going to do Rm equals 6PL minus B, right? And Mm equals 6PL times P, 6PL times L, 6PL squared. That's this way, minus 2BL. Okay? Actually, in this whole, maybe later we can use the hinge method here, but we really don't use the hinge method in this problem. You can here, I can do it quickly.
I thought the whole point was that we wanted to have fun using the hinge method.
I can use it here. I will use it. But, okay, with this one, in order to find delta B right, I need this little segment plus the angle from all of this.
Yeah.
So first let's find the angle. So this is, what do we call this? D. So we need phi D, which I'm going to write here. It's easy for me to write up here. Phi D is long.
Alright, that makes sense.
Phi D is long. Okay, phi D is 2P, 2L, 3L, 5L plus 3L over 5L EI. That's the first term. Here's 5 terms. The next one's for sure. 4PL,
Plus.
yeah, 5L over 3 minus 2BL 5L. Minus 6PL 5L over 3I minus PL G 5L over 3EI. Does everyone see where every term comes from?
If you wanted to do conjugate,
Yeah.
Why 5 plus 3L and not 5 plus 2L?
5 plus, because it's this side, you add the other side. For phi A, you add L plus B.
For 5 what?
For phi A, you add L plus B.
Oh, okay.
Okay?
Rocky, and where does the first term come from?
The first term
Comes
is,
the 2p in the middle.
that's, yeah, the 2p that's not in the middle, the 2p that's off center.
If you were to use a conjugate beam, you'd find the reaction at D.
Okay. You wouldn't use the conjugate beam for everything.
No,
If you
no,
wanted to
from
do the
the
conjugate beam
2p,
for just the 2p,
you find the reaction at,
after doing it, you find a reaction at D. You're also going to need the other one because we're going to need the angle on both sides.
and the forces are the area of the triangles.
Just make sure you also have to do the moment equation.
Yeah.
Okay. We have that term, yes? Okay. So now what we have left is just from here.
Who's on, what did you say?
What?
Is the new one?
This is getting really cool. Okay. What we have left is just this little segment. Okay? And we have
can see both screens. Just don't go too off to the far side.
Okay, you'll tell me if I'm off. This I'm going to call delta B right prime. Okay? And delta B right prime is equal to 3p plus b. Second times 2l to the third over 3ei. Okay? And due to this and this, we get delta b right is equal to delta b right prime minus 5e times 2l.
You assume it's down.
Because I assumed that this direction is going to go down,
It makes it
that means
down.
this is going to go up. Okay? And that angle obviously comes to that. Okay? So that's now, this is equal to this, is our first compatibility equation. By the way, what are our three compatibility equations? I just stated the first. What are the other two?
The other side as well.
We have, right, delta G right and left, and what's our third one? Our third one is here. We can say one of two things. Either we can say the angle here doesn't change, or that the offset, the displacement here doesn't change.
Then why can't you see the angle at M is 0?
Because here, this little structure here is quote-unquote determinate.
It's not though.
It's not, but there's no extra support. So this little structure is determinate as far as compatibility equations
Can
go.
you say that the angle at Q has to be 0?
Okay, so that's the first compatibility equation, more. That's the first compatibility equation, right? These two are equal. The second one is going to be here, that delta G right and left are equal. The third one, we have two options. No matter which one we pick, they're going to be the same. They're going to be a linear combination of the previous ones. Either we can look at this structure and say that the angle here doesn't change, which we'll get to in a second, and make this a fixed support, or we can leave this as a clamp and take this away and make it just a force, and say that the delta there has to be 0. Okay? Those are the three equations. So we got the first one. Okay? Now notice we can't solve because we have here B, B, and G. The whole equation is made up of B and G. So we're going to, if once you add these two together, once you get this is equal to this, you're just going to get left an equation with B and G in it. So it's actually not so ugly. Okay? Tell me when I can erase.
It's all recorded for posterity, so.
Okay. This I can erase.
That's such a satisfying noise.
This I can erase. Now, I'll also do the reactions here quickly. This I can erase. I'm not going to need it again. This we're going to need one more time.
In what situations would we use the moment method?
I'll show you when we get here. I'll do it with that one.
Like, how do we know?
Well,
Just 'cause there's
I'll show you.
If you want next whiteboard, just to keep your equations up.
No. Because I'm not solving. I'm not solving it.
You guys should leave this here permanently.
Yeah, it's a good.
It's nice.
I use my whiteboard most of the time. Okay.
Nice.
Now, just like we did here, let's quickly do the reactions here. Okay? What are the reactions? We have RD, and we have RF. Okay? What's RD? I'll do it here. Erase up there. What's RD? It's 3p plus b. And we're going to do them both simultaneously. Okay? RF is 3p plus g. Now we have to start factoring in the moments. Okay?
Hey, do you think the method she used where you do delta M over L, that?
That's always how you do it. And distance here, remember, is 5L. We'll get to this. Okay, and the one last thing I have to do to add them is this. This is going to be 2p over 5L times. This RD is the one that's closer, it's going to be the longer one. So it's going to be times 3L. And this is going to be 2p times 2L over 5L. Okay? Now, that's all of those except the moments. Okay, we didn't take care of the moments yet. Now let's do the moments. So let's start with GL. So it's now we know whenever we have the moments, let's say I had a beam like this. These two we know are going to be opposites. It's just a matter of which direction each one has. So if this is 2L and this is PL, the reactions here for whatever direction, I don't know what the direction is yet, but their magnitudes are going to be P over 2 and P over 2. And they're going to be in opposite directions. Which directions? The opposite of the arrow. So there's going to be up and there's going to be down. Right? So, in this case, we're going to have something, we're going to have now GL over 5L. So we're going to have G over 5, D over 5. Which way? This way is going to be up. So for RF it's positive and for this it's negative. And it has to satisfy equilibrium, so these have to be added to 0. Now we're going to have 4P, 6P, and 2BL. The 2BL, again it's 2B over 5, 2B over 5. This one has to go up, this one has to go down. So for RF it's negative, for this one it's positive. For the 6PL, so we have 6PL over 5P, so it's 6 over 5P, 6 over 5P. This one has to go down, this one has to go up, so for RF it's negative, for this one it's positive. And for the 4PL, we have 4 over 5P, 4 over 5P. And now this one has to go up, this one has to go down, so for RF it's positive, for this one it's negative. Those would be your reactions.
Can you explain again why we're taking into account moments for reactions?
Here.
Do we always do this?
Sigma M,
Since ever. Okay?
Jenna, sigma M at each reaction, at each support.
RA.
So he's not doing a sigma n, he's doing a r.
Actually, I am.
It's been
Why?
Like sigma M. If you, okay, let's do this one. Okay? Do sigma M around A.
PL
Okay, so here. Sigma
minus
M here, this way is our
times
positive.
2L.
Huh? Okay. Here, you want to do the other way?
PL
So we have minus PL.
plus RB times 2L
Okay.
is equal to 0.
So RB, 2RB equals P. So RB equals P over 2.
Okay.
Right?
Why
So what did I do? RB is P over 2. This is now going to be P over 2 this way. By the way, does anyone else have this question too? Or is it just Jenna?
I wouldn't necessarily do it this way.
Okay. But that, okay,
You're just
basically,
doing it
whenever
wrong.
you have a moment,
This is still
look at this, look what I just did.
Still going
This is
strong.
M, and this is,
No, this
L.
one, this one.
I'm going to call this curly L. Okay? Each of these have magnitude M over curly L. The L of the whole thing. Okay? And their direction, that's the only thing that matters. No matter where this is sitting, right? Okay, so look what I did here. GL, which is our M. So I did GL over, what's the whole length? 5L. So I get G over 5. Right? That's the magnitude of both of these. Which direction? Well, if it's going like this, these have to create a couple this way. So it has to counter. So that's all I did with the plus and minus, that's all I'm doing. Just whenever I'm looking at something, I'm doing the M over L, and then figuring out which direction counters it. If you want to do it by taking the moment around here, it's fine. It'll work just as well. But this is what you'll get. Okay?
But that's only for moments, right?
That's only for moments, yes. For a force, it's, if this is, okay, I'll do it up here. Hey, your other eraser, that was convenient. For a force, when I have L, and this is, let me not do L, let me do A and B,
I got a new eraser, it's this.
okay? When this is A and B, the force here, they're both up.
Is it weird?
This is P,
that's
P
really clear.
over L, this is
It's
P,
over.
A over L. Okay? More. For the force, that's what it is.
The force?
For the force, that's the way it is.
Okay.
It's always the opposite one. And if you think about it This one's closer, so it has to have a larger force to create the same moment. Okay?
It's like
Yes?
Inception.
Okay. Now the reason I like having these on the side of my page is, when we get our solution, because like you saw before with the delta L right, the delta B right and left, you're going to end up with an equation that's, you're solving for B and G. So once I get to the end of my work, I'm going to get a solution for B and G. But now I have to go back and plug in all of those, and I have to start looking at what I did. So if I do it now, I can remember, I'm looking at the situation, I never have to look at it again, and now I just have this equation that has B and G in it. I'll give it another 5 minutes. Okay? Another rocket, by the way. Now I just have a solution with B and G in it.
Where?
What's up, Baza?
It alarms every time.
No, that's just an alarm that I should go.
Oh.
Okay, now I have B and G, and now I can solve for them. What I'm going to say is, since we did delta D here, I'm going to assume you guys can do delta F. If you don't have it, it's right here. Okay, it's relatively the same thing, just the other side, just with a limited amount of time I have. Okay? So assume now I found delta F, so I can find delta G left.
Right?
Left. Delta G left on this side.
Okay.
Okay? So now it's just a matter of finding delta G right.
Same thing we did on the other side.
Okay? So, for this side,